Hello. So we'll study a small topic from chapter 4, that is motion in combined electric and magnetic field. That means if you have both electric field like this and magnetic field like this, so such that they are both perpendicular to each other, then if a charged particle enters perpendicular to the magnetic field like this, perpendicular to both magnetic field and electric field like this, what will be the force experienced by this charged particle, or what will be the motion of this charged particle? That is what we are going to see. So we will have electric field, perpendicular to that we will have magnetic field, perpendicular to these both we have a charged particle Q. So this charged particle Q will experience a force due to this electric field, that is F is equal to Q into E. And due to this magnetic field there will be a force experienced by the charged particle, that is B, F is equal to Q into V cross B. Okay, so then we will see the total force will be sum of these two, then we will solve and see. Okay, so let us see. So assume electric field is perpendicular to magnetic field as I have drawn over here. Y-axis represent electric field, Z-axis represent the magnetic field. And the charged particle is perpendicular to both E and B. Over here you can see a charged particle which is in the x-axis direction, and V is the velocity with which the charged particle is moving. So as per the theory we know the net force on the charged particle will be due to both electric field and magnetic field. So I can write it as total force will be equal to Fe plus Fb, and Fe is actually QE and Fb is actually Q into V cross B. Now in the next step what I am doing is I am just considering the directions of this electric field, magnetic field and this velocity. All these three are vector quantities. Over here electric field is along y-axis. So the unit vector corresponding to y-axis is j cap. So for electric field I will write it as Ej cap. That means electric field is in y-axis direction. That is the meaning of Ej cap. Okay. Now for velocity I'll put Vi cap. That means velocity is in I cap or x-axis direction. And magnetic field is K cap. That means magnetic field is in Z-axis direction. Okay. So I'll just write it like this. And here over here I can write Q into V into B into I cross K. So when you do I cross K, it's mathematical operation. When you do I cross K, you will get the answer as minus J. Okay, so you will study that in maths. Okay, so instead of I cross K, I can put a minus J over here. So what will happen to the equation QEJ plus QVB minus J? So this minus I can put it on here. So QEJ cap minus QVBJ cap. Over here Q is common, so I'll take Q common, E minus VBJ cap. Okay, so J cap means the net force will be in J cap direction. That is the meaning. Okay, that is in the y-axis direction. Now what we need to know is we are going to try the force to be 0. Okay, so what to be done for making this force to be 0? So force will be 0 when Q is 0 or E minus VB is 0. Okay, Q can never be 0. All the charged particle will be having some charge, like it be a proton or an electron, it will have a charge. So charge can never be 0. So E minus VB, we can assume for force to be 0, E minus VB will be 0, or E is equal to VB. From here we will get a relation V is equal to E by B. What does that mean? If a charged particle enters this combined electric and magnetic field with a velocity equal to E by B, then force will be 0. I'll just show it to you. See, as we just discussed, let this electric field be 20 and Newton per coulomb, and this magnetic field be 5 Tesla. Okay, then if any charged particle enters this combined electric and magnetic field with a velocity equal to E by B, that is 20 by 5 is 4 meter per second, then what will happen? The force experienced by that charged particle will be 0. So this particular charged particle with a velocity 4 meter per second will go without any deviation. Okay, so the main application of this comes when we have a large number of particles with different velocities. From that large number of particles, we just require the particle with a particular velocity. For example, we just need to sort out the particles with a velocity 4 meter per second. So then we can use this technique. You will make a chamber with electric field and magnetic field in it like this, and according to the requirement of the velocity, we will set the magnitude of electric field and magnetic field, and only those particles whose value of velocity is equal to E by B will go through that chamber without any deviation. Okay, otherwise this charged particle will experience a force and it will take a circular turn. Okay, that we already studied. Any charged particle enters a magnetic field, the motion will be helical. So if there is some force, it will take a helical motion. If the force is 0, the charged particle will go without any deviation. Okay, so hence all the substances with the velocity v is equal to E by B can be selected. So one of the application of this technique is in velocity selector. Okay, so in velocity selector we use the principle force experienced by electric and combined electric and magnetic field is 0. Then we will tune that velocity selector accordingly. Okay, so thank you.